Getting my screen?
Yes, ma'am.
Okay. So let's start the today's lecture. So again, welcome to this lecture, and it is again on architecture of microprocessor 8085. The content of today's lectures are: first is review of lecture number 5. Then we are study today the instruction register. Another content is about the information about the instruction decoder, and one more content we are again study in that lecture, that is the program counter. So these three blocks we are covered in that lecture. So just going to the first topic, that is the review of lecture number 5. So in yesterday lecture we study about the program status word, or it is also called as the flag register, or another name is also given as the processor status word. So yesterday we are observed that our flag register is consist of 5 flags, and each flag having their own importance, and each flag will show their particular status. So we study about the carry flag, auxiliary carry flag, parity flag, zero flag and sign flag. So in carry flag and auxiliary carry flag, we are observed that whenever microprocessor perform the arithmetic operation of two 8/16-bit number, then the carry whatever is the generated after addition of two 8-bit number or 16-bit number, result may be a maximum of 9th bit or 17th bit. So that 9th bit or 17th bit is copied into the carry flag. While in auxiliary carry flag, we are observing that whenever we are adding the two 8-bit number or two 16-bit number, in such case, after adding the 4 LSBs, whatever be the carry is generated, that carry is copied into the auxiliary carry flag. Going to the another flag, that is the parity flag. In that parity flag, we are calculate the number of ones, and number of ones indicate the parity of that number. So the number of ones present in 8/16-bit number is known as the parity, and according to the number of ones present in that number, we are indicate the parity of that particular number. So if the number of ones are odd, then such parity is called as the odd parity, and in such case parity flag becomes 0. While if number of ones are even numbers, counting, if in that 8-bit number, if you are count the number of ones and if it becomes the even number, then it is called as the even parity, and in such case parity flag is becomes 1. Then zero flag also indicates the status of a particular number, and here we are observing that in zero flag, whenever the microprocessor performs the arithmetic operation of two 8-bit numbers, after adding the two 8-bit numbers with each other, if your result is the 0, then 0 flag will give their particular status. And if your addition of two numbers, and after adding two numbers, if your result is the non-zero, in such case Z flag will the status is equal to 0. Again, we yesterday study about the sign flag, and in that sign flag, if you want to add the two sign numbers with each other or subtract the two sign numbers with each other, in such case sign flag will give the particular status, but for unsigned number there is no need of the sign flag, or in such case the sign flag will never give the any status. So if the result is the positive, then sign flag will show the status S is equal to 1, while for the negative, sign flag will show the status is equal to 0. So in this way, we are covered the yesterday lecture, or the content of yesterday lecture. Now today we are going towards the another topics, that is the instruction register, then instruction decoder, and next one is the program counter. So just going to the architecture of microprocessor 8085. In that architecture, still we are study this block B, C, D, E, H, L, and also yesterday we are study the temporary resistors. So these blocks we are study. Then accumulator is over. then ALU is also over. Flag register, just yesterday we are covering these two content. Now today we are going towards this block. That block is named as instruction register and instruction decoder, and one block that is called as the program counter. So first of all, we are observe the capacity of that particular block. So just observe the program counter. Program counter is also designated by PC, and here the number is written as 16, means program counter have a capacity to store the 16 bit of content. Getting? Now going to this block, that is the instruction register and instruction decoder. So instruction register, यहाँ पे register बोला है, means nothing but it is also one of the storage that this block is also used for the storage purpose, and again the number is written as 8, means here we are storing the 8 bit of content. But this program counter, instruction register and instruction decoder having some proper chain for the execution of instruction. So now one by one we are know about how the program can be executed, or the instructions which are available in the program, that how that instructions are executed one by one in sequence, that we are now studying. So just I have write down here one program. 4 instruction program is there. Move A comma B, move B comma C, move C comma D, and halt. This is the assembly level language program, because microprocessor here we are in microprocessor 8085, we are write down one program in terms of assembly level language. And what is meant by assembly level language? It is nothing but whatever be the task we want to perform in the program, that task we are write down in terms of some coding language, and that coding language is called as the assembly level language. Okay, so here MOV is stand for move A comma B. A is also our accumulator and B is our register, general purpose register B. Similarly, here I am using the general purpose register C as well as D. So this is 4 instruction program is there, and now how this program can be executed in proper sequence, that we are now discussing here. So whenever we want to execute any instruction, at that time instruction register, instruction decoder and program counter play an important role. This whatever be the instructions we are written here, that instruction are in terms of English short form, or it is also called as the mnemonics. So the process of transferring the opcode of that instruction through the program counter, that process is called as the opcode fetch operation. ये जो यहाँ पे instructions लिखे हैं, that instructions are not understanding by the microprocessor. ये instructions microprocessor easily understand नहीं कर सकता है. So for that purpose we want to convert that move A comma B, that English short form जो है उसको हमें convert करना पड़ता है एक opcodes में. Opcode is nothing but the operational code, and that operational code is the standard for each instruction. For example, move A comma B के लिए opcode अगर होगा आपका 10, that is the standard for the assembly language program. So first of all, whatever be the programs we are write down here, so that program's instructions is converted into the opcode. अब इस पर्टिकुलर इंस्ट्रक्शंस के अपकोड कैलकुलेट करने के बाद उस अपकोड्स को एग्जीक्यूट करना means nothing but the fetching of opcode from particular memory location to the instruction register. That process is called as the opcode fetch operation. So here suppose this is first instruction is there, move A comma B, and this instruction I consider as the opcode is the 10H, while the second instruction is move B comma C, The instruction having the opcode is 0 to H. Another instruction, that is move C comma D, having the opcode is 03H. And last is the halt, that is also one instruction. Assume that this halt instruction having the opcode is 04H. So whenever we are write down the program and we want to execute that program practically, first of all convert that whatever be the programs are there or instructions are there. First of all, find out the opcodes of each instruction. After finding the opcode of each instruction, that opcodes are stored in some proper memory location. तो ये जो हमने opcodes निकाले हैं, सबसे पहले प्रोग्राम लिखना पड़ता है. After writing the program, for execution of that program, we are calculating first the opcode of each instruction. सभी के इंस्ट्रक्शंस के अपकोड्स निकालने के बाद वो सभी अपकोड्स वन बाय वन इन सीक्वेंस से, जिस हिसाब से आपकी प्रोग्राम के इंस्ट्रक्शन है उस सीक्वेंस के हिसाब से हमें ये अपकोड्स कोई एक पर्टिकुलर मेमोरी लोकेशन में स्टोर करना पड़ता है. सपोज आई हैव स्टोर्ड दैट ऑल अपकोड्स in a memory location starting from address 0000H. So this is the address in which I have stored the opcode 10H of instruction move A comma B. Similarly, the next instruction is move B comma C, whose opcode is the 02H, and that I have stored in the next memory location, that is 0001H. Similarly, the move C comma D having the opcode is 03, and that I stored in the another memory location, that is equal to 002H. Likewise, I stored all four opcodes of that particular instruction in a memory location. Now I want to execute this program. मुझे इस प्रोग्राम को एग्जीक्यूट करके देखना है और आफ्टर एग्जीक्यूटिंग आई वांट टू चेक द रिजल्ट आल्सो. ओके, so for execution of this instruction register, instruction decoder and program counter play an important role. अब फर्स्ट इंस्ट्रक्शन को हमें एग्जीक्यूट करना है. So for execution of first instruction, I want to transfer address where this opcode is stored. The first instruction opcode is stored in 000H. So whenever we want to execute the move A comma B, the move A comma B having the opcode is 10H. So that is stored in the memory location 000H. So I have to transfer this address of that particular memory location into program counter first. इस इंस्ट्रक्शन को एग्जीक्यूट करने के लिए इस इंस्ट्रक्शन का जो भी अपकोड जिस पर्टिकुलर मेमोरी लोकेशन में स्टोर्ड किया गया है उस पर्टिकुलर मेमोरी लोकेशन का एड्रेस सबसे पहले हमें ट्रांसफ़र करना पड़ता है प्रोग्राम काउंटर में. जस्ट ऑब्जर्व this block diagram, and here this program counter having the capacity is the 16 bit है capacity program counter की. And here also the memory address is 4 hexadecimal address, 4 digit hexadecimal address. Means if you are converting it into the binary form, it become a 16-bit number. So this 16-bit address of this particular memory location is first of all transferred into the program counter. Whenever we want to execute the instruction, this address, first memory location address, we are transferred into the program counter. जैसे ही ये एड्रेस प्रोग्राम काउंटर में आ जाता है, after that this 10H, which is nothing but the opcode of move A comma B, is fetched into the instruction register. When this address is available into the program counter, after that the content inside that memory location, which is nothing but the opcode of move A comma B, is given to the instruction register. Instruction register having 8 input lines and it also having the 8 output lines. It indicates that this instruction register will store the 8 bit of content, and if you are observing that our opcode is also a 8 bit content, operational code is also our 8 bit content, right? Because here 10H means 2 digit hexadecimal number है ये, means उसको अगर हम बाइनरी में रिप्रेजेंट करते हैं तो it becomes a 8 digit binary number. So this opcode is transferred into the instruction रजिस्टर. ये opcode किसके ऊपर, इंस्ट्रक्शन रजिस्टर के इनपुट के ऊपर आ जाएगा. जैसे ही प्रोग्राम काउंटर में 000H ट्रांसफर हो जाएगा, दिस कंटेंट विल ट्रांसफर इनटू द इंस्ट्रक्शन रजिस्टर. And instruction register is nothing but it consists of an flip-flop. Naturally, since the name is the register, means it is made up of flip-flop. 8 flip-flops are there, and this 8-bit number, that is 10H, is transferred into that flip-flop. Output of instruction register is connected to the instruction decoder. यहाँ पे इसका आउटपुट कहाँ पे कनेक्ट है, इंस्ट्रक्शन डिकोडर को. Naturally, the outputs are 8, right? Instruction registers के output क्या है, 8, and it is nothing but the input of the decoder. Means here the output of the decoder is 2 raised to the power 8, right? Because inputs are 8, so if you are calculating the output of decoder, it becomes 2 raised to the power 8. Means 256 outputs we are getting at the एंड ऑफ द डिकोडर. इस डिकोडर के अगर हम आउटपुट कैलकुलेट करते हैं तो आपके आउटपुट कितने मिलेंगे, यहाँ पे 256 आउटपुट. एंड इन ईच आउटपुट वन इंस्ट्रक्शन सर्किट इज कनेक्टेड. ये जो यहाँ पे 256 आउटपुट रहने वाले हैं, उस हर एक आउटपुट के साथ एक इंस्ट्रक्शन सर्किट कनेक्ट होती है ग्राउंड के साथ, राइट? सो व्हेन वी आर ट्रांसफरिंग द 10H into the instruction register, according to that number, one of the output of instruction decoder is activated, and suppose 10H के लिए आपका wide 5 is activating. For this particular 10 number, suppose our output of the decoder is Y5 is activating, and Y5 output is connected to one instruction circuit, and that instruction circuit is nothing but the instruction move A, B. जो भी ये आउटपुट हर एक इंस्ट्रक्शन के सर्किट के साथ कनेक्ट रहते हैं, वो इंस्ट्रक्शन सर्किट इज नथिंग बट मूव A, B की रहेंगी. जो अपकोड यहाँ पे ट्रांसफर हुआ है उसके हिसाब से वॉट एवर बी द आउटपुट इज एक्टिवेटिंग फ्रॉम इंस्ट्रक्शन decoder, that output is connected with the instruction move A, B. So in this way, this instruction is executed by the microprocessor 8085. Just we are consider the only one instruction, move A, B is executed by this sequence. For execution of move A, B, first of all we are transferring the address of that memory location where we are storing the opcode of move A, B, that we are transferred into the program counter first. So 000H we are transferring into program counter. When it is available in the PC, the 8-bit content inside that memory location, that is fetch on the instruction register. Fetch, or it is transferred on the instruction register. Means 10 opcode is transferred on your instruction register. And depending upon that number which are here available, that opcode, that is stored in that instruction register, and output of instruction register is connected as a input of the instruction decoder. So according to that 8-bit numbers, the input of the decoder is considered, and as per that input of the decoder, one of the output of decoder is activated, and that output is connected with the instruction circuit of move A, B. So in this way our first instruction is executed. After that we want to execute the another instruction, क्योंकि हमारा प्रोग्राम तो पूरा execute नहीं हुआ है, only one instruction we are executed. Now we want to execute the another instruction of our program, that is move B, C. So for execution of move B comma C, the opcode of move B comma C, where it is stored in 0001H. The move B comma C having the opcode is 02H, and it is stored in which memory location? 0001H. And for the execution purpose, we want always the memory location address into the program counter. जस्ट पहले हमने देखा कि मूव ए कॉमा बी की इंस्ट्रक्शन एग्जीक्यूट करने के लिए हमें सबसे पहले ये एड्रेस प्रोग्राम काउंटर में ट्रांसफर करना पड़ा था, उसके बाद हमारा ये जो अपकोड है वो एग्जीक्यूट हो गया था थ्रू द इंस्ट्रक्शन रजिस्टर एंड इंस्ट्रक्शन डिकोडर. बट नाउ फॉर द एग्जीक्यूशन ऑफ मूव बी कॉमा सी, the opcode is present in the another memory location having address is 0001H. बट प्रोग्राम काउंटर में कौन सा एड्रेस गया हुआ है? स्टार्टिंग में 000H. मीन्स प्रोग्राम काउंटर में ये एड्रेस गए है अवेलेबल 000H. सो फॉर एग्जीक्यूशन ऑफ अनदर इंस्ट्रक्शन इन अ प्रोग्राम, जैसे ही आपकी फर्स्ट इंस्ट्रक्शन कंप्लीट हो जाती है, after completing the first instruction, program counter content is auto incremented by 1. It is auto incremented by 1. जैसे ही फर्स्ट इंस्ट्रक्शन एग्जीक्यूट हो गई है, इंस्ट्रक्शन सर्किट पे वो इंस्ट्रक्शन आ गई है, आफ्टर दैट द कंटेंट ऑफ प्रोग्राम काउंटर इज ऑटो इंक्रीमेंटेड बाय 1. तो प्रोग्राम काउंटर में कंटेंट क्या था? 000H. उसको 1 से ऑटो इंक्रीमेंट हो जाता है. Means the new content available in program counter is now 0001H. Getting? Means जैसे ही फर्स्ट इंस्ट्रक्शन कंप्लीट हो जाने के बाद प्रोग्राम काउंटर का कंटेंट वो ऑटोमेटिकली 1 से इंक्रीमेंट कर देता है. सो नाउ द प्रोग्राम काउंटर हैविंग द मेमोरी लोकेशन एड्रेस 0001H. तो जैसे ही मेमोरी लोकेशन का एड्रेस प्रोग्राम काउंटर में मिल जाता है, दिस 02H, that is the opcode of instruction B comma C, is fetched by the instruction register. 02 is fetched by the instruction register. ये 02 इस inputs of the instruction register के ऊपर ट्रांसफर कर किए जाएंगे through the buses, and this is the in instruction register the new opcode, that is 02H, is available. And again according to that 02H, input of the decoder is connected, and according to the input of the decoder, one of the output of decoder is active, and that decoder output is connected with the instruction circuit through which having the instruction move B comma C. So in this way, the second instruction is also executed in this sequence. After executing the second instruction, program counter content is again auto incremented by 1. So now the new memory location address which is available in the program counter is now become 0002H. So 0002H is available. So 0002H का कंटेंट क्या है? अपकोड क्या है? 03H. तो जैसे ही ये एड्रेस प्रोग्राम काउंटर में आ जाता है, this 03H is transferred on the instruction register, and in this way the third instruction, that is move C comma D, is also executed. In this manner all the 4 instructions are executed in that sequence. So in this way, for the execution of any program, any instruction, microprocessor use the program counter, instruction registers and instruction decoder. These 3 blocks will play an important role for execution of any program. Getting? So in this way we are executing the all instructions which are available in the program, and according to that execution, microprocessor will show the output. So with this we are stop here. Have a nice day. Thank you.